Yo. Yeah, we got a new cam. Well, we got a new lens. We got a different angle. We're angled. Where's the music out? Oh, I hope so. I've thought about it just enough to not have thought about it enough, and then like, oh yeah, surely particle systems aren't that hard. All right, let's get into this mode. Yeah, I've made a little particle system, a 2D particle system before, a little basic one, but I don't know how hard it's going to be to do a 3D one, but we'll see. Should probably make a mission statement. To do stream 28. Particle accelerator. And we'll need the emoji. We might need fireworks. Oh yeah. What are the things a particle like? Stars. That looks particle-y. Yeah, I used to do texturing for like Octane render, and they had some, or in Cinema 4D, man, they got some noises in Cinema 4D. They got a whole arrangement of noises. Maxon noise shader. They have all these noises built in, and I mean that's not the biggest deal now, but in like 10, 12 years ago, it was pretty cool. Octane render was really cool. I liked the look of Octane render. Okay, mission: create a particle system. One cool thing about, I guess, can you do the same like triplanar mapping that you can do in Substance? It's got quite a lot of stuff in the library, like, you know, noises and grunges and all that. And the masking system's real nice. Okay, we need to create the data structures and the looping, what do you call it? And the data structures and systems. Then we need to get it to render quads. This has got a B. I want to do a data experiment here. Get it to render quads, make something cool with it. Yeah. I see what you're saying. Sometimes when I look at like really fancy assets or VFX shots and stuff, I'm like, I bet you they're using like Grunge One. Put it in there. Never gonna give up on the Blender advocacy. Hey, I'm a big advocate for Blender, alright. Blender is like taken over so many. Like I used to use Cinema 4D only for all VFX stuff, and then it was just completely gone once Blender like hit 2.8 or whatever. Houdini though, and they're even not attacking, but they're even giving Houdini stuff with geometry nodes, you know. Houdini's awesome. Have you used Houdini? It's awesome. It's just awesome. Even if you can do a lot of it in Blender now, it's still like, as far as software goes, it's a very clever software. Working today on a particle system. So theory, I don't know what I'm doing. Also, I think I know what. I know what I'm going to do. I don't know if it's the best idea, but we're not going to make the best particle system. We're going to make a particle system. So am I now on the right mode? Yeah, I am. Okay. Oh yeah, I did some conceptualizing around the wind system, theorizing the way the wind should work, and I improved it a lot. Alright, this looks like a good place for a particle system. Particles. I can't see the chat though when I'm like this, so maybe I'll just move this window up here. Okay. Houdini has the advantage of being GPU accelerated. Geometry nodes is all on the CPU. Yeah, it's kind of like, I guess it's the way it's built with the nodes is like, it feels like you're getting us closer to how programming might. It was a big awakening for me about like how not how computers work, but how like it's more of a programming mindset. But I never learned like Vex or anything like that. Once the tutorial's like, and now just write in this code, I'd be like, oh, can I not also? So as far as I'm thinking particles. There's a particle. There is a particle. Here's where I want to do an experiment, because I'm going to make this two ways and see which one's faster. Particle, which is just like a position, maybe a rotation, a scale, and a color, or something. That's the current particle. You could have things like texture animations and stuff, but we're not going to do that for now. And then a particle system, or like an emitter or something, which has like an array of particles. A particle array of n particles, however many particles are in this thing, or that could be like the max particles. And then you could have like a count depending on what you use. You could use a vector for this. You might not want to, because vectors do like heap allocation, and you might not want that. You might just want it to always be set to the max, and then just have a count, and have a way to remove dead particles or reset them or something. And this has other things like rate and area or something of where it spawns. The particle thing, the particle system can be really big, like start color and end color and all this. And these probably need also like a lifetime, a life? Because these would be like lifetime. And then for each particle you like go, you add to its life or subtract its life, and then you can use that life delta to figure out where it is between the start and end color, for example, or the opacity or the size or whatever you want to do. So this is all like the CPU side stuff. Well, unless you write a compute shader, which I'm not going to do because I don't know how. Maybe one day. And then there's a question like, when you send it to the GPU, what do you send? I was reading about this because you could send a matrix for every particle, like a model matrix, and then on the GPU just do the drawing of the fragment shader or whatever. You can do billboarding on the GPU, So you could make it face the camera because you've got the view in the camera. Then the other option is to send the position and rotation and scale and calculate the matrix on the GPU. So this is like an offset or something. I was reading about that. So I don't know which one's faster. Probably the GPU one. But also, if I do that, then I need to make a shader, and I need to make custom instancing for the particles. So there could be like the fast way, because right now I've already got the system that whenever I load a model in, if I made a quad with a texture on it, I could load that into the current renderer and it would set up instancing and everything, and then I could pass a matrix for each particle, and it would be a bit slower, but it would mean I immediately get to render things. And then the slow way would be write a custom shader, write a shader, instancing, and a draw for the particles. I don't mean that one would be faster to operate. I mean one would be faster or slower to do, to make. And because, you know, I'm streaming for a couple hours, 3 hours or whatever, I'm just going to see if I can get it going. But the thing I wanted to test was the idea that you have one where they actually instance a bunch of triangles and use a sort of alpha mask to create a circle from it. Yeah, so those are the kind of weeds I'm trying to avoid a little bit. And the idea of like data, the idea that like you have a particle, and then in the system you're going for each particle, or for each particle, right? Particle P, you're going particle, update the position, particle, update the rotation, da da da. So you're loading one particle and then you're doing all the operations on it, versus if you had your particle system doesn't have an array of particles, it's got an array of life, position, rotation, scale, all the components of the particles, and these are all arrays the size of your particle system, whatever that is. And then you do 5 loops and you update all the lives, update all the positions, update all the rotations, update all the scales, and then all the colors. And apparently this way is supposed to be faster, because every time you pull a particle off the memory, you're pulling something that is potentially too big for the cache line. Sorry, I'm repeating a lot of stuff that I hear. So this is why I want to try it out, because I don't know. And I don't know how many particles you can fit. Maybe you can't even fit one. So you go to get the position, and then you got to actually keep going back and fetching particles because they don't fit in the cache. Whereas here you can load, like, if life is just a float, if this is an F32, then you can actually fit quite a lot of them in the cache, and the CPU will just go grab you a bunch and you operate on all of them really fast. And so the amount of getting, because apparently getting from the memory versus getting from the cache is like, it's like 200 times slower or something, even though it's still like nanoseconds. But I thought that this would be a good time to try something like this, because it's kind of straightforward. Well, I mean, you know, it's kind of, it wouldn't be a huge mission to implement it both ways and then just see which one's faster, I guess. So yeah, that's what I'm gonna do. That's what I'm gonna try and do. I don't know if that's as interesting as anything, but we're going to try it. We're going to try it. We're going to try it. And what we need is to make some stuff. Anyway. Theory. So there's going to be a Genie system. So we need to add a header. Maybe we'll have this all in its own thing. Genie particles. You know, I think that daisy chain's particles, I don't imagine them needing doesn't need like millions of particles. Not a class. Okay. So this needs to include the Genie pch.h and include the Genie.h. And this needs to include the Genie definitions.h and b namespace Genie. I don't know why it always does that. And Genie probably should also include Genie particles. See if we build, not build release. Cool to use particles for the train smoke. Yeah, this is exactly the type of thing I'm thinking for the train smoke. And the train smoke is going to be what, like hundreds of particles, not tens of thousands or something. So we don't need... I mean, I built a real dumb one in Space Game, which was just all it was vectors of particles, and I didn't do any kind of optimization. I just iterated through the particle systems and updated all their stuff, and then used the Raylib draw rectangle or draw texture, and that's nicely batched, so that creates a vertex array and stuff. And that supported hundreds of thousands of particles without really trying. So I'm thinking it shouldn't be too bad. I'm hoping. Okay. So we need a struct called a particle system. And I don't even know right now, do we need a particle as a thing? Oh yeah, we'll do it. Well, we're going to do it both ways. So I don't know if I need this type diff or not, but I'm going to do it. And we'll try the Vic3 position, Vic3 rotation. I don't know what kind of rotation we're going to support. Vic3 scale. I could just use a float for scale, I guess. But what other things did we have? We need a lifetime. F32 life time, not lifetimer, lifetimer, life. Timer? I'm a lifetimer. When it comes to this stuff, I'm a lifetimer. What else do we need? Color. And you may not even need to store the color on the particle necessarily. It depends on the way that we're doing it. I guess you do because you want to send it to the renderer or something. We'll have a look. Okay, so that can be our particle. So we have particles, and this could be like max particles. And we'll just chuck one here. Max particles, and we'll put 10,000 for now. I32 particle count. Color, start color, end color. I've been loop, burst, color over time, size over time. Oh, they're fun games. Oh yeah, for the particle system. Size over time. Yeah, true. I'm just gonna do a F32 start scale and F32 end scale. And you could do these in ranges as well. So you could say pick between a thing. So you could say F32, or you could say a vector 2 life duration, and then you could say between X and Y, or between min and max. Yeah, I might just have them as separate things. Lifetime. This is not like supposed to be a perfect implementation. This is just trying to get it going. So we can have some variation on lifetime. We could do just drawing points. OpenGL can just draw points, so that could be a good way to start without having to worry about the textures. This is another thing. I think it would have a texture pointer to whatever the texture is. This is not going to be like, obviously, as robust as like the Unity particle system, but it's more just going to be like, what am I going to use it for? And I'm probably going to use it to draw textures mostly. What else does the PS need? All right, this is this, and then depending on whether we want methods or not, particle count, we'll just set this to 0. Start color equals, we'll have a default of color white. End color equals color. We'll make it fade out, so 1.0 F, 1.0 F, 1.0 F, but 0.0 F. Start scale can be, don't worry about start scale now. We'll just do these as 1 and 1. Lifetime min and max. 1 and 2. Equals null. Here's the thing is, you kind of want a particle system. Because how many of these particle systems are we going to create? Is this more like an emitter? I don't know. Because we also need to grab Andy here. Yeah, I figured it was Andy in the with the Funk Games head helmet on. Type def struct particles particle manager, or something better than that. I don't really have managers. And this has We could use a vector here just because we're lazy and we want to preserve memory. Particle system, particle, yeah, we'll try a vector. This may change. Particle system, whoa, I almost did a camel case. Particles system. I guess we don't really need that. This could just be in the Genie itself. Because then when we go to genie.h, we probably want in Genie a... Yeah, we'll have a particle manager. Particles. Is that going to be particles, particles? Particles, particle systems manager. Some good wide code there. Okay. Particle systems, particle manager. We could have a method called void update. We got particle manager update. And then here, namespace Genie. And we didn't put these into a namespace, did we? Particle manager update. What's your problem? Do we need like... Hello there, David Delassus. I feel like everyone needs a little shout out. Fun games. Dragon. Void. Particle manager update. What's your problem? Oh, not the build release. Bruh. What did I do? Is not a class or namespace. Yeah, I know that. Wasn't it? Wait, where are we? Genie, particle manager. I didn't make a namespace. But I made a... Did I not do a thing? What have I done? Why am I confusing myself? Oh, yo. Particles in Blender. Particle manager. Oh, particle manager. Oh yeah, did I spell it wrong? I want you to build debug only. Oh yeah, I found that. If anyone was here at the end of the last stream where I got struck down by a bug after building a level that was too big, it was the dumbest bug. It was actually quite a cool bug. It was satisfying. Debug. All it was like every ship was writing all this debug information to this generic thing called debug text. This debug text, and all it does is create a log of texts and then draw them at the end of the frame to an IMGUI window. And this max text draw strings, if the log count is greater than the max text draw strings, which is quite small, it's only 64. This was written, I had copy pasted it from wherever the debug log is, max log entries, which is 1000. So it was writing, once it wrote the 65th or 64th drawstring, it would write that into the, it would just overwrite some memory in the renderer and set. It was so weird to debug because I was going through here and I was stepping through the ship update function, ship update, and I brought the renderer in here to see its values, and it was like on ship 4, suddenly the renderer object count would go to like 1 million, and I was like, on what line did it even do it? It did it on this, I deleted them all, but it was debug logging all this information. And that's how you overflow C-style arrays. For I32i is particle systems dot size. So this is update each live particle system. And we could be naughty and put a thing in here, void update. I love it. I actually kind of like it because it trains me to think when something goes wrong, like the first thing you think is, my first initial thing was like I've overloaded the renderer with too many draw calls and something, or with like too many objects, or but I was like, and then you start thinking, I've definitely, the adjacent memory thing, you start, that's caused some interesting problems, and you start to think like, oh, I've probably overflowed something somewhere. This is why you should probably use vectors and stuff. You should probably use vectors. Is the standard template library considered a dependency? Particle system reference system equals particle systems I, and we'll do a sys index, and then you can say system.update. Oh, it's the height of technology here. Void particle system update, and then update the actual particles. So for I32i is going to be particle count. So this is, we're managing our own count. We're not using vectors to like resize arrays and stuff. And then this would be like something like, oh, we need a velocity. Yeah, this is where I was confusing myself about velocities. This would be like initial velocity, and it needs to be a vec3 really. Velocity equals, and we'll construct one that goes, and this way you need like a random range. We'll just do vec3 up. Why am I getting no autocomplete? VS Code's been really buggy recently and slow. I don't know what I've done to it. We need to create particles as well. We need to create particles. So this particle thing needs we'll start with a F32 emission rate. This can be every 0.2 seconds or something. And then a F32 emission. This is turning into a emission timer. equals 0.0f. So we create particles, we say 32 delta equals genie clock dot delta time. Do I just have a function that says get frame time? Get frame time. Get clock. Get frame time. Well, why don't I use that? Create particles. So we go timer. What is it called? Emission timer plus equals delta if emission timer is greater than emission rate. Make a new particle. I enabled Copilot, tested out, and started auto-completing a bunch of nonsense. Yeah, I feel better since I turned off the autocomplete because it makes you program differently. I do ask it questions all the time. Although I was trying to do something yesterday and it was a major bummer, dudes and dudettes. I was trying to do like some techie effects with frame buffers, and it didn't go well. The game does render to a frame buffer now, which is some sort of progress. So first we'll set the emission timer equals 0, and then we want to do make a new particle, which is something like if particle count is less than max particles, then particles and particle count. We could get the particle if we wanted to. Particle reference P equals particles particle count, and P dot position equals, we'll just do them from a point. So this particle system will also need we'll start with just a point, world position equals vec3 0. In fact, we'll move it up a little bit just so we can see it. 1.0f and 0.0f equals world position. Using AI to write things on its own feels like someone else doing it. Even if it works, it's not the same. Yeah. There's some things where, like, I don't know, like, the problem I was trying to solve yesterday was, even trying to get going, was like, render the scene to a frame buffer that's got a color texture and a depth texture. And I'm like, yeah, I get fundamentally what's going on there. We're taking the depth information and rendering it to a texture. And then I wanted to use that depth texture in the ocean and sample it. And it's like, how do you sample a depth texture into the space? And it was like, oh, you need the normalized device coordinates and the thing, and then re-project it into the thing. I'm like, dude, how am I ever going to figure that out? But it didn't work anyway. And then it gaslights. Sometimes it just gaslights you, and it's like, do this and this and this and this and this, and it's real confident. You're like, okay, and then it doesn't work. P dot. Do we need to store velocity on the? We probably do. Vec3 velocity. And what I don't know is, like, does the velocity, you give it an initial velocity and then you slowly dampen the velocity. You could add gravity to it. We'll just do a constant velocity equals velocity equals initial velocity. P dot scale equals big 3 1. Color equals start color. P dot rotation equals big 3 1 or 0. Alright, so that technically writes some data to the last particle at the end. One thing about particles though is, are we going to directly remove them during the particle loop, or are we going to flag them for removal? Because then now we're talking about like bool, alive or something. This may not be the good way to do it. This means we'd need 2 particle loops, which I don't know whether that matters. We'll see. Oh yeah, good call. I try not to do it in that call in case we need it again. This one here, I try not to put it there and then do it and then forget to do it. You're right. You're right. Correct. So it's kind of particle ref p. You could do this in a backwards loop. Is one way to do it that might work. I equals. We'll actually name this p index, particle index, particle, and we can set this to the particle count -1, and as long as it's greater than 0 or equal to, we want to operate on the 0th one, particle index minus minus. That's one way of doing it. Is that what you want to do? I've got a, where do I have a negative thing? Oh, that's leave if it's while it is less than or equal to 0. Yeah, I think that's right. I don't know. Maybe you can't link. Particle p equals particles p index. Get the particle dot position plus equals particle dot velocity times, probably times this by delta. Particle dot color, we're just gonna go equals color lerp start color. Maybe we should extract the thing here. I don't know. F32 life delta equals particle. We want to increment the p dot life timer plus equals delta p dot life timer equals 0. Are we counting up or are we counting down? I don't know why I so confidently think I can jump on a stream and do this. It's probably better to do it quietly alone in your own silent life. Life delta equals p life timer over okay, so we've got different lifetimes, so we need to store the lifetime as well. Lifetime. I'm like, this will be trivial to do in a data-oriented and object-oriented way. Lifetime. P dot lifetime equals random range between min lifetime min lifetime max random. So what are you complaining about? It has no member lifetimer, but when I click there, it's there. Over particle dot lifetime. I don't like doing this life timer and life clock, so maybe I'll call it life clock. It's not great, but age. Yeah, true, age. Particle age. Okay, so the color lerp, the start color and end color by life delta. Dun 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 dun. And then we could, because we're doing this in the reverse way, it might, wouldn't that maybe also make particles get updated twice in a frame? Because like, say you got all these particles, particle, 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 and this one, oh no, this is pretty cool because this one is dead. So it grabs this one and puts it into its place and then moves on going this way. What if this one, it'll just override itself? I guess it doesn't matter. I'm not really understanding what life delta is here. Oh, so this is basically a 0.0 to 1.0 like t value of life. So it just, you know, like when you want to get the percentage of how far along its life is age over its lifetime, like health over max health. Current health over max health equals, I don't know why I call it delta. The name delta. Okay, yeah, cool. Yeah, delta I think is like, because in here the color lerp, you got T, which is kind of is the delta the difference? Is that right? Or is this life T? Maybe delta's like difference, right? I don't know whether that's quite right. Delta is A must be ratios A over B. So what is T? Why is it called a T? Is that for time or something? What is the thing? I want to know this now. What is, oh, come on, man. What is the T represent in lerp? What is they're basically a blend factor. So it's kind of like a blend factor. The blend. But there's probably a mathematical thing for it. Lerp is linear interpolation, so you move A to B using time step. But it's still like 0 is the first value and 1 is the final value, and all the things in between. Life be over age of 0 to 1. Oh, why does the chat sometimes not update? Age is how long it's been alive for, and lifetime is its maximum life. So this could also be called max life, but I don't like that. Lifetime sort of sounds like how long it's been alive for. You could just call this life. Life duration. You could do like that. Age over life duration. If I guess we don't need to do this. We can kill this here. If life t, if page is greater than p dot life duration, and we can do this all the way up here actually. We can do a remove particle. Delta time is time since last frame, so current time. Yeah, we can actually see where we get, how we get frame time. This just returns this clock, but the clock itself is, current is get elapsed, clock draw, clock frame is clock dot update plus clock dot draw. I stole a lot of this from Raylib, I'm not gonna lie. Oh, and this is the wait thing. This actually works. Yeah, so it's managing, the clock is managing current frame, previous frame, update time, draw time, frame time, target, base, frame counter. Yeah, it works. Remove particle. So we want to say particles p index equals particles particle count minus 1. So replace with the end particle. Move particle unordered. And then particle count minus minus. And then continue. We don't want to carry on. We continue the loop there. This is remove particle. And then we do that. Then we color alert the particle. And then what else do we really need to do? They last for 1 second, so they're probably going to hit max. Oh, it's 10,000. Usually do A equals lerp A to B, so every time you call it, it gets closer. Yeah, that's like the Unity lerp. Whereas this is like this is more of like a, yeah, that's the same thing really, it's the same thing. But here we're lerping between the start and the end because it's going to give us 0 to 1. Is there anything else that needs to actually happen? We need to draw the particles. We could do something like this is going to be highly irregular, but we're going to go void draw. Because I just want to see if I can do this. So this is particle manager dot update void particle manager draw. How do you draw How do you draw dots? Draw points. OpenGL. How to draw points officially. I don't care, I just want to draw them. Begin GL point. Begin GL points. This is fast. GL begin. GL end. Oh, here we go. Learning, blah, 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 pixel points. 3D point, the vertex. Drawing points, gel clear, begin, gel points, end, and then swap buffers. So can I just do a thing where I go gel? What is gel begin? Oh, that's just a beginner draw call. And we say GL points. There is no GL begin. What is it in the renderer? I'll be in graphics. GL draw elements. GL draw. What do I want here? Is it draw elements? Draw buffer? Whoops. Drawing a point. There was a OpenGL particle system. I was watching this video. He was doing compute shader stuff, and he's like, "Yeah, you just draw a point. Blah de blah, blah de blah. I just want to draw a point, sir. I don't want to deal with shaders and stuff." Down, da 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 down. Maximum GL points. 1 million points. Okay, I don't care about all this. This is where I'm just like, this is where I say, how can I draw a point using OpenGL? Begin. GL enable GL point sprite. Allow shaders to control point size. I don't want to do any of that. Why did it say that there's no GL begin? There doesn't seem to be a GL begin. Build. Is it going to get to particles and be? There is no GL begin. Okay. You use vertex buffers. Oh, that's some old thing. Yeah, there doesn't seem to be. Okay, yeah, it's old. Okay, so I do need to have an actual thing and draw it. I just wanted to debug this. But whatever. It just means a bit of fluffing around. Does it? How much fluffing around does it really mean? I was thinking, because I have a system set up to like load models, textures, whatever, and batch them and draw them instanced, I could just make a quad. I could just author a particle quad and bring it in that way, and then just have a draw call on it. I mean, have a batch instancing. It'll just go through like the shaders and all that, which I don't know whether I want to. Okay, whatever. I'm just going to do it that way. I don't really want to program quads and do that manually right now. Okay. Add a mesh, a plane. Perfect. So that is a that's a cube, a 1 meter cube, that's the size of a cell, then the particle will just make really small, whatever. All transforms, or maybe rotate it that way. And then, just for fun, toasty noodle coming through. You know the old ways. I do not know the old ways. I don't even know the new ways. So I thought maybe why don't I draw one of these sakuras? That might end up being a particle system candidate. It's a pretty big texture. This is a 1K texture. So is there a resize? Scale resize? The scale EU. Oh, and it changes the actual thing. 0.25. 256. Oh, you don't know about Pixel Composer? You don't know about Pixel Composer? Look at this program. This is the best piece of software on the marketplace right now. So cool. Scattering, scaling, draws sprite things. It does everything, this thing. Look at all the things that it does. Look at all the things. It's even got it's got 3D. It's got simulations. Rigid sims, flip fluid, smoke sims, strand sims. It's made by one dev. And it's made in Game Maker. How good. Love it. Save current frame. We'll just save it here. Blossom.png. Pretty good. Pretty good. Good enough. Oh wait, we actually need to author this object, don't we? My bad. Shader editor. New. Blossom. Texture. Bring it in. Dun 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 dun. Textures, models, textures. Blossom. Give me the blossom, that looks good. Give me the alpha. Nice. Dun, dun, dun. Roughness can be high. Link to a website for tween functions other than lerp. Why would you want to do that? Models. Let's just. Why wasn't I on this giant folder thing? Particles. It seems total overkill to fully load this. Genie GLB. Blossom particle. Blossom quad. It's a little bit of overkill, but it saves me having to think about how to do it. So I guess I can just straight up say we're going to have to construct a matrix. Which is a bit wasteful. Position equals p dot position dot rotation. Oops. Rotation equals p dot rotation dot scale equals p dot scale. Alright, why do I always want to put those in there? And then render add static model to render. The model will go game. Oh, we don't know what this model is, do we? Maybe we'll just store it on there because one thing I am. Model, pointer model. Note, using the model system for testing. Look at that monkey in the background. Easings. With the dot at the right place. Oh, we want to have a particle system create thing, don't we? Go away, particle manager draw. Go away. Okay, so we want to draw the model. We want transform to matrix of the XF. Then the tint color can be the P dot color. Oh, lovely. Note, constructing a transform and converting it to a matrix. And this is batching. And we need to make sure we load this thing, and maybe we have a way to create a particle system. Void. This is not in here. Void create, and we can take a bunch of ugly parameters here. We can say model pointer model victory world position. Color start, color end, color. We could have another one that just constructs the particle system and then just sends it, and then just send it. F32. Maybe we just want to just give me a particle system. Construct it yourself. Build it yourself. I will not help you. Whoa. It doesn't know how to do things. It doesn't know how to use void particle manager create. This is not good naming. What did I name it? Create system. Create system. By the way, also create the system for me before you send it to me for creation. Particle systems dot push back system. No maximum, no theoretical maximum. So game models.h, we need to store this. Genie model pointer. Blossom quad. We'll just call it Blossom. Oh, stay ready. Hold that energy. We're going to see blossoms flying into the air before we, oh whoops, I need game models. grass, pine tree. It's not really a pine tree, is it? Game models dot blossom equals genie models load model. And did I create it? Did we successfully create it? Shaders models particles blossom quad copy paste. No, not the right copy. Copy? Does this work? Yes. And make 10,000 of them. Load mode. Right now it's going to render through the PBR shader, which is going to be a little crazy. But is everything currently kosher? So maybe we're gonna need a way to update this stuff. We're gonna need a ngenie.cpp on begin frame clock update. Maybe in game system shutdown. Do we call genie stuff from the game? Tween update. Update the thrust of the begin frame somewhere here. Genie. Oh, we need to make an explicit call. But maybe it'll be in Genie somewhere. Begin frame. Begin frame is not actually... Oh, it doesn't matter, does it? You can say Genie particle manager dot update. It's there. There it is. And then in world or something, on a knit maybe, right at the begin, we can say particle system, test system dot. So these are going to be all defaults, but we just want to set the model equal to ggame models. We're going to make sure that this happens after models goes first. That's probably a good idea. Models dot blossom, and just like that. What else do we need to set? Test system dot. Let's see what happens. Does anything happen? Bets on if anything happens. Oh, we're not giving it a random velocity right now, are we? We're just saying it's the initial velocity. So they're all just going to go straight up in the air. How do we do like a... I want to do like a... some sort of... in a unit hemisphere or something. Vec3 velocity equals, we'll just say Vec3, V3 up. So it's straight up and down, but then we'll say velocity dot x equals random range between negative 0.5 f and 0.5 f. Is that gonna be like nz, and then set the velocity here? It's gonna add the velocity to it every frame. We'll see if anything happens. A single point will be rendered on the screen. That looks like a What am I looking at here? Stack Overflow. That doesn't seem good. Where did we crash? Let's see if we can get to here. World init. So this, oh, we create the particle system. Do we Stack Overflow when we create the particle system? We never actually sent it. We never actually added it. Is a particle system too big? It's hard to know where we're actually crashing because of that Stack Overflow. Yeah, it has a static array of 10,000, you're right. Boom. Okay. But why does it crash there? If I get rid of this, do I still crash? Okay. Definitely cannot just create particle systems on the stack. One minor failing to our... That's pretty big, yeah? Is this why we need a vector? Okay, we'll do it the vector way. Vector of particles. Particles. Now, this is like, can you still do it? You can't do it like this. You have to do a push back now. You could do a thing on particle systems. System dot particles dot reserve max particles, or resize. You could do like this, max particles, and then go system. Or is this going to cause an overflow as well? No, it shouldn't. Clear. Functions the same way? Particles. Yeah. Well, one of them, I don't know which one of them, yeah, vectors on the heat. One of them does resize, creates, and initializes the particles. Reserve maybe just allocates zeros. Should we see what the difference is? Either way, you still got to clear it. Or maybe you don't if you use reserve. We also never called that function, so that would have been particle system test system equals game model blossom, and then Genie particle manager dot. It should be add system, shouldn't it be? Did I put a breakpoint there? Yes, let's see what happens. I mean, this is probably not the way to go to use vectors, but also then act as if they're like C-style arrays. But maybe it's good because the allocation only happens at startup. So right now particles is capacity 0, size 0. If I step over particles is capacity 1, 10,000. But then when we resize it, now particles actually has a particle in every spot. And that's is the only way you can use it like this. You could use pushback. Let's see how far we get this time. Or maybe you can't just use it like that. Particles P, particle count is 0, particles. Say what? Particle system, particle systems. There's 2. Why are there 2? And particles size is 0 anyway. Why are they 0? This is some confusing stuff about vectors. Why are there 2? Clear just sets it back to 0, but it retains all of the 1s, doesn't it? So it's still got a capacity. Oh. How did I do this? I did this. I thought clear didn't clear the actual data. I thought I did this in a lot of places in the editor. Creating like a temp thing. Come on, vector. Vector, string vector, 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 vector cell neighbors. Resize. Clear. In the editor, cell matrices dot clear. We got that there, that there, that there. I thought I was using it that way already. Maybe I should do reserve. Is there another one that's like clear but not clear? Okay, I guess we'll have to do pushback. We can just say particle P and then set the particle and then say, this is where you go in vector land. Right. I thought it didn't destruct. I thought there was a way I was like setting them and then just setting the count back to 0, but maybe. Oh yeah, we could maintain this thing and then not clear, right? Would that work? Either way, it's probably not good to mix and match the way you do things like this. Okay, we still crash. And we crash at particle systems P equals particles. It seems bad that the capacity is still 0. Even though we've reserved. Is this because we pushed it back afterwards and it didn't? Vectors confuse me like that. So looking, again I've got 2 for some reason. And the particles is size 0. Particles 1, particles size 0. Alright. Resize. Okay, we'll try resize. And then otherwise we might have to just go full. I don't know why there's two of them though. Oh look! Particles! Oh, we need to set them to double-sided. Hey! Beautiful. Could have relished that moment a little longer. I just want to test this and just make sure it's not making two for some reason. I might have some smoke from an old project from an Embergen thingamabob. Capacity 2. So this one is model Blossom Quad. And what's this one? Oh, I know why this is. This is because worlds, this is not where you want to put this particle system. Because this world init, I forget this world init note. This gets called on every world load. Not just the first. I had it for a little while. I think I trialed it. Let's get this guy and put it in. We'll just chuck it in game. I think it's awesome. I think it's a great software. You know, that's written in Odin by and that's where the guy who wrote Odin, he works there. He's the head engineer, I think. Quite impressive. Very impressive. Game models. We need to also then do this render object reference blossom object. Or maybe we don't need to do that. Maybe we need to go ggame models.blossom dot materials 0 dot double-sided equals true. Ginger Bill. Now that didn't set it. We need way more particles. This is not enough particles by a long shot. Game. Test system dot emission rate equals 0.02 F. So why can I not get the thing there? Is it material 1? Is that going to crash? Oh yeah. Yeah, dog. It's funny, the alpha blending, that's another consideration because why are they not changing based on, whoa, my TV just go away, man. Don't ever hijack my thing. Why does timescale not affect the movement? Position plus equals velocity times delta. We got delta, right? Is that correct? I didn't buy the full version. I only needed it for like a very few little thingamabobs. Continue. Yeah, that seems right. So why can I not slow the game time and see the change in particle age plus delta plus equals velocity times delta? This just gets delta time, right? Clock frame. Oh. Is it different to if I went clock dot delta time? Have you got the full version? Are you a full version enjoyer of immersion? Beep, 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 beep. Okay, get frame time doesn't even. Yeah, you can see it cuts out on these ones that are like fading, depending. They need to be drawn at the end because there's no transparency sorting right now. So they are fading out, they just look a little weird. Control new. If I hit Control new, we should just have our lovely blossoms particling. More. Yeah, been working at VFX for 2 in development games using it. It is a pretty powerful, I mean, if you think how long it takes to do those kind of sims in Houdini, you do trade off a bit of like tweakage. You got a lot of tweak time. 0.02. And then I want to kind of also want to do some debug stuff maybe. This will be a lot more particles. How many particles are in the particle system? Particles. I guess we can do this in debug. We can do it in debug. Is there, we got a little debug UI? We got anything good here? This is the log options filter. That's the log, begin log console, draw log window. Oh yeah, I'm in the wrong place altogether. Is there a thing called Genie UI.cpp? Does this have a begin frame? We don't really want it in here. We want it somewhere in here. Draw screen space. Does particles happen? I guess we can have a particle debug. Particles.h. We can have a void draw UI. Void particles draw UI. Alright. Nothing is complete without IMGUI. IMGUI begin particle manager. IMGUI end GUI, and for starters, we can IM GUI text. We do IM GUI. I hate writing IM GUI as a word. Columns to IM GUI column width of column 0 of 175 or so, and then text particle systems, next column IMGUI text %d ggenie particle manager dot particle systems dot size. You can use a ZU here, and then we can do 4 2I is in Genie particle, should be here, particle manager dot particle systems dot size. Do particle count. I guess we can do GUI text system number % ZU and I, or I32 or D. So number I, next column. Lovely. Particle count. Particle system ref sys equals ggenie. I should have just cached that. Particle systems I. Sys.particles dots. We can use the particle count. Particle count. Oh, we need to draw this UI. Do I call it from here or something? Genie particle manager dot draw the UI. Got some particle data going on. Particle systems. I did that really well. Oh, you probably can't even see it over there. We'll just leave it up here. That's 400 particles. It's nothing. What did I do wrong here? Columns 2, column width, particle systems, and then next column. Oh, we need a next column. In fact, doing this inline is silly. Maybe just do it like that. And then we go system number, 2 next columns, and then a next column, and then a next column. Perfect. Boom. It'd be cool to actually have a little controller for the particle system rate rather than... Oh, you can do that? Beautiful. System 0 particle count. I think the only thing to do is up the juice. Put another 0 in there. Particle count doesn't seem to be... Did that make a difference? If I do that, that was a super fast implementation. I'll take it. Was it a good implementation? Who knows? Oh yeah, that does change the thing, but how come if I do that, is this just, it is creating one every frame, but we're maxing out. This might be delta time dependent. I can't get any more particles. I can't make it more than 400 particles. But I want a lot of particles. I want a lot more particles. Create more than one per frame. Yeah, I guess you could. What is max particles? 10,000. Guess we'd have to write a little thing in here. You could create one every frame by making the thing. I guess just what's the actual delta. If I made this release mode, we might get a slightly different result. Did it? I almost feel like that's lower than our frame time, so it's just always going to create one. But I would feel like if it's going at like 500 frames a second, it'd make more. Dun, dun, chicka, dun, dun. Alright, there we go. Now we got 2000. We were delta time locked. It's funny, at this point, they just disappear on a certain angle. Okay, so currently the particle system does almost... Oh, it does do something. It does do something. What I want to do is have a... We need a way to add and remove particle systems. Well, whatever. Yeah, I want to do an actual stress test where we're like making lots of particles. And then try this data-oriented shenanigan, which is probably going to be a pain in the ass. Bang. But we've got some ragtimes, so I'm happy. Notes.txt. Create the data structures and the systems. And then the data experiment. Okay. We still need the systems. Void. Remove system. And we're going to need an I32 system in ID. This is where we have a lot of fun with IDs and indexes. And I hate it. I don't like thinking. I don't want to think about it. Ding, ding, ding. Emission rate. Well, that's what I thought I was doing, because this emission rate, if the emission rate is over a certain amount of time, then emit a particle. That's how many particles per second. But then that's frame dependent now. Maybe you don't want delta, maybe you just want time. But then that's real time. Maybe you do want real time. Genie clock dot current. Or is it elapsed? Let's see what happens here then, eh? We're going to need to be able to add and remove particle systems, so we'll do it. Well, that's 700. Are we in release mode or debug mode? Release. It's funny how it creates like a square. A pyramid shape. 2000 particles. Okay, so it's based on the frame rate. Because if I open like Sakuda, it goes down to 500. And then if I go to new, it goes up to 2000. It's alright. I think this will be alright for now. Because I don't really need particle systems to make over this many particles. But what I do want to be able to do is add and remove particles systems. Create system, void, particle manager, remove system. I32 system ID. And I don't quite know how we're going to know unless this sends us a pointer to a system. We could say, and then we hold that pointer somewhere. But then if we're doing unordered removes and stuff of particle systems, then that's not going to work. So we could do like a particle system is available particle systems. Because how does someone know what the system ID is? And is that state supposed to be changeable? What is how do you even remove things from? Because if you remove something from a vector and then it rebuilds itself somewhere. Anytime a vector resizes, any pointers to its data are no longer valid because it reallocates. All fun things to think about. But I think I could just do something simple like, always this introspective music when things get tough. Particle systems, system ID equals particle systems dot size -1. So this is another unordered remove. And then particle systems dot pop back. And then in the debug this draw UI thing, I'm gonna have an IM GUI button called delete. We're going to say if IamGUI button delete. We're going to go ggenie. Let's just get this within particle manager. Particle manager ref p manager ggenie particle manager. Yes, get the manager. The p manager. I'm the p manager when it comes to my dogs. I mean, wait, that doesn't sound right. P manager.particle systems. We can say, we can also get it here. How many times do we have to write this out? P manager. We can say p manager dot remove system I. So there's a delete button. Find out if that works. Bim, 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 bim. Delete. Okay, we can delete a particle system. Maybe we'll have a button, IamGUI add, IamGUI button, add system, add sys. If IamGUI add sys, then let's do like what we did in the game. We'll just get this. Ding 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 ding. Particle systems test system. Oh, we need the blossom. It has no concept of the blossom. It doesn't know what the game is or what the blossom is. I guess we could just make this model. We'll make a model available to the renderer or something. We'll just make a little model. A cheeky little test model. Particle test model, and this can even be a pointer, so we don't have to load it or anything. We'll just set it directly in the game models over here. Genie renderer dot particle test model equals g game blossom models dot blossom. Bam, 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 bam. So we can get the genie renderer dot particle test model. Nice. And then we can create the test system. But we want the victory position equals victory position equals 0.0 if, or we'll just inline a random range between -5 and 5 on the X. We'll do it at 1.0 and oops, and another random range for the Z. That looks good. Does that not look good? Oh, we need another dot. Okay, so this will create a random test system in a random position, kind of. And then it'll create little info about them all. Add system, add system, add system, add system. Where are you, systems? Oh, I didn't set that position, did I? test system dot position, world position, zinger. Add system, beep, 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 beep. There they go. It's a little far. Beep, 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 beep. So that's 42,000 particles. That's a lot of particle systems. Let's get rid of, oh yeah. Control new, oh yeah, there we go. So 20,000 particles takes 2 milliseconds. Doesn't seem to be on render frame. It's not the rendering, it's the iterating probably. So we need to, if we're going to make a test, let's make these like much smaller, or maybe 2. I wonder what whether this doing this. So we go a new frame and we add 10 particle systems, which gives us 10,000 particles. Well, it all depends, doesn't it? The render frame takes 100 microseconds, so drawing these particles no biggie. Even though it's using, is it using the lighting and everything? Looks like it is. Fully rendered. It doesn't care. And it does depend on the zoom as well. We could do a profile on here. How do you do this? Profile. Function timer. Timer. And it's called update particles. So that'll just auto destruct and give us the thing of how long it took to update the particles. Update particles doesn't take long, but with 10 it takes 700 microseconds, which becomes the longest thing in the game. To deal with, each one's got 1,000. So yeah, roughly 10,000 particles. This can be our test. I had a phone call. Is that an important one, do you think? I might just call them back. Sorry, I had to consult with the mystics about the particle systems. Hey, Michael. Just skipping by. Yeah, nice one. Yeah, I'm working on it. I did notice that by slowing down the timescale, you get a massive bump in particles. In fact, I get a message anytime a render object goes above its limit and resizes the vector, and it resized them up to 50k, 75,000. There's a hard limit on instances of 100,000, so by slowing it down, it makes more particles per second. There may be something wrong with that. Well, so you can see, I don't know how you're supposed to fix this, but it's the order in which they render is not like correct for opacity. So are you supposed to sort all these particles in 3D space before you render them? Update particles takes 3 milliseconds for 43,000. That doesn't seem very fast. Yeah, who's doing that? Okay, we're gonna get a baseline though, because we're gonna data orient this madness. Particle systems 10. Is that enough? Or should we have 20? 20 systems takes 1.1 milliseconds, but you can see it as the frame rates go down, the amount of particles go up. Interesting. Let's take this as a, oh no. If I hit delete, I can delete them. Beep, 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 beep. We need to do a thing called IMGUI push ID I, and then IMGUI pop ID. So this gives each button its own ID, I think. Sorry about the phone call. I had to talk to the gods about particle system management. Okay, 20 particle systems minus the grass. Let's just take a screen of that. And I'm going to put this up here. Wait, particle systems 20, okay. Print screen. It's our little info for that one. 15,000 instances at 1.1 millisecond for compute. So it'd be cool to have, I could try and build it in line with this one, so they both exist and you can flip a switch or something. I don't know how hard this is going to be, so just bear with me. Particle, but we got a coffee, so things might be excellent. How do we make this a fair fight? Do we want two different types of particle systems, or do we just want to... We don't really have this bull check. We don't use this, do we? So we can get rid of that. Also, the color doesn't need to be stored on the particle, because we just calculate it and then send it. So this could just be a color and send in the color. So they don't need to know what their color is. We could also get rid of that. Velocity, all this stuff is probably needs to be whoops. Okay, the new paradigm is to have this is going to be a bit of a nightmare because we're going to need to use vectors again. We'll use vectors and see what happens. So we do life durations, vector F32, we could say particle life durations, particle ages, vec3, particle positions, vec3, particle rotations, particle scales, particle velocities. Yeah, you don't want the particles to know what's coming. So let's also system dot p ages dot resize to max particles. We'll just straight up initialize these suckers. Lifetime, life durations, positions, rotations, scales, velocities. Is this the way? 1, 2, 3, 4, 5, 6. 6. Max particles. It's a little over the top. Hey Pine, what's happening? We got particle systems working. Somewhat. They're a little freaky right now, but technically they function. Doom, doom, doom. Hey! Blossom fountains. Where can I... Oh, I'm pushing the wrong button. We can beep, 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 beep. Yeah. Okay. Kind of nice little, but we're doing a data-oriented test. We're going to split the components of each particle into arrays, and then we're going to loop each of these arrays instead of looping over one object. And we're going to need a bool data oriented equals false. I don't know much about data oriented, so I don't know if this is actually gonna work, but we're gonna try it out. We'll put this up here. I am GUI, then we can say next column, and we'll go I am GUI checkbox. Data, oh, this should be a turbo button. Turbo. Yeah, that's the idea. If I'm GUI checkbox turbo, oh, and we need the actual value. Oh, this will auto do it. This is data oriented. Next column. Okay. Why can't I next column there? Oh, we've got an if statement. We don't need an if statement. We're just going to go turbocharged. And we're going to find out just how turbo it is. Bowling. Bowling, good times. Okay. Why is this erroring out? No errors. So particle system update. Make a new particle. If particle, and then in here we can say if data oriented, else not data oriented. Right? Correct? We need to do P ages, okay, and this is particle count equals 0.0f. So we lose our constructor kind of. P life durations particle count equals this random range shenanigans. Boom. P positions equals world position. We could make them come out of something that's not like a fountain. P rotations equals, oh whoops, particle count. We'll align our arrays just for the sake of it. P rotations particle count equals vec3. Why don't we do a random Y rotation just for the fun of it? No, we'll keep it. It's just going to be the same as the other one. Heard Odin does the unrolling auto magic. I know. I saw a guy do it, and I'm like, wow. I don't understand. What? How? Scales particle count equals vec3 1. Oh, this should be 0. And there's another one, P velocities particle count equals vec3. Let me just copy this. Velocity. Man, I need just a full playlist of ragtime music. And I guess we want to always increment the particle count. 1, 2, 3, 4, 5, 6. So that's fine. We create one on them. Then we update the particle. And we have to do a if data oriented. I wonder if switching is just going to completely destroy this. We're not going to be able to switch. It'll be okay. Don't worry. Else. Dun, 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 dun. Dun, 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 dun. We need to get P ages. This is taking ages. P index plus equals delta. If const expression data oriented. What? I think I won't, I'll just make it not toggleable in the editor because that'll break things, I think. Okay. And then if p ages p index dot is greater than p index. Wait. No, this is not how to do it. We need to loop through each of them. This is wrong. Is this chaotic? Update the actual particles. This is update all the components. Yeah, we gotta loop each array. If data oriented is static const, this would remove the branch at compile time. All right. Yeah, I'm gonna get rid of that. I'm just gonna make it as a define. I'm gonna define it, I think. Or yeah, or I'm gonna make it static. I'm gonna make it const expression. I'm just not gonna put that button in there because this button is bad. Where is this button? You go away. You could switch it if there are no particle systems alive, maybe, but I don't really want to find out. Okay, 4. Now we need to do I32I. Maybe we can do I32P. Just use a P operator. Oh, I hate it when it does this. I'm like, okay. Particle count. P ages P plus equals delta. If P ages P greater than, this is where we got to do a couple of lookups, so it's not optimal, but I don't know how else to do it. P life durations P. Then we want to, there's probably going to need to be a thing called remove particle. I'm just going to have a thing called void remove particle and I32 index. Oh yeah, we should be doing this backwards looping on all of them, shouldn't we? We should be P equals, well, I guess we could just do the removal last and do that. This one should be backwards. Particle count minus 1 particle is greater than or equal to 0, I think. P minus minus. This is annoying because then we have to get, I guess we could just, isn't the whole point of this to not have to look up multiple things at once? Maybe I'll do this one last. We'll just do the other ones. For I32P particle count, P positions P plus equals P. Oh, we still need a velocities P. We still need to load in 2 things. I guess whatever. We'll see if it makes a difference. Position. What else do we actually update? Color. Colors. P color. Oh, we don't. This is a little tricky. Maybe we need to store the colors now, because then we still need to go through. How do we make a render at the end? We still need to look up all these infos. Life durations, ages. Well, that's all we're doing, is updating the thing, and then it's like straight to draw. Remove particle P. Maybe we will do this first. Age. Age and position. So we still need to do this render as static model, and it needs transform and a color. So maybe we make a vector of colors and transforms. I don't know. Map for P colors, P. Oh, whoops, that's P matrices colors, and this can be color. Okay, maybe I'm not smart enough for data-oriented design. Color. Loop it again, brother. P colors. P equals color lerp. Still need to do this color lerp between start color and end color. And the T, we have to get P. I guess we could store that in another thing. P life. Again, I'm gonna deltas. I'm gonna write life deltas for some reason. I feel like my life delta is changing. P life deltas. P equals P ages P. I guess we could grab it, not have to keep looking it up. Over P life durations. This is like how not to do data-oriented design. P life deltas P. I like all the P's. And then do we need to like construct? I guess we could do it here. P matrices, P equals transform xf dot. So this is the thing, you want to keep the workload in each loop small. Position equals P positions. P matrices equals transform. This is probably a lot of work to matrix xf, and and then just one more loop. Batch. Particle count. Render. Add static model to render. Model. P matrices. P. I feel like this is error prone as well. P colors P. Oh, we need to remove this particle also. This is important. So it's like this, but we've got to do all of them. P ages index equals P ages particle count minus 1. I guess we could do I32 end equals particle count minus 1. And we'll just call this I. End. P colors I equals P ages end. Oh, not ages. Colors. Yo! Life deltas I equals. Welcome back to this incredibly exciting episode where we muddle our way through things. Life deltas end. P life durations. This is a lot of stuff. P life durations end. Matrices I use P matrices end. P positions I, how many things? P positions end. Rotations, scales, and blah. I just want to copy these. Why am I writing them every time? We don't even have okay, so let's just check. Data oriented is false, so this should just run the regular one. We don't even have, this engine doesn't even have any sound. No sound capabilities. Oh, camera's a little hot this whole time. Okay, the regular particle system works. Nice. And are things going to explode? I think they are. Okay, life deltas capacity is 0. Oh, we need to also, we added a bunch of more things. Deltas, colors, and matrices, right? Yeah, the game engine doesn't support anything. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9 things. That looks about right. We've got choo-choos over here. Wow, it looks perfect. Oh, you know what? That might be working, but I just maybe forgot to add delta into that. That might actually be working. I feel like it's going to be slower. Okay. Add system, add system. Doosh, doosh. It looks exactly the same. Oh wait, did I even turn it on? It is on. It looks like it's exactly the same. Add systems. 10 systems. We got 10,000 particles. It's running at 1.4. The update particles is 700 milliseconds. What was our last one? Let's have a look at our high-tech. Update particles took 1.13 milliseconds. Oh, that was 20 particle systems. Okay, how much? It's like exactly the same. Like exactly the same. We're getting a few more particles. Update particles 1.13. Although for some reason we're getting it's about the same. It's about exactly the same. Made no difference. So what did I do wrong? Is it probably because I'm like getting things too much and doing too much work in these? I'm doing like the same amount of work. It's probably this transforming to matrix, which is like the heaviest part of the puzzle. What does this do? This does like too much. And like going and getting one from another array, and it probably matters like what order they're in. Like you're like, oh well, life deltas is close to this one. Does this change anything? What are we talking about here? We're talking about like the smallest difference. Add systems. 20 systems, again, it takes the same amount of time. False. It's interesting how it's like exactly the same time. Like, is it just doing so much optimization that nothing we can do affects it? Wonder if it makes any difference if we go higher. $40 takes 1.5 milliseconds. 50 takes 1.8. So it is kind of somewhat. So 50 is like 1.8 milliseconds. Doom 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 doom. Beep 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 beep. Oh, we better get rid of all the grass. Oops. Beep 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 beep. 1.8. Yeah, it's the same. What particle systems? This is 200,000 particles. I don't think it's ever gonna. So So what's taking up the time? I guess that does add up to like 3. What happens if I turn off enable screen buffer? Doesn't make much difference. Well, it still renders, even though huh. Well, you know, I guess with a shader, that does some billboarding or something. It's certainly easier to manage the non-data oriented way. So maybe we would just not do it. What was our plan? Data experiment. We did it. It wasn't very exciting. Get it to render quads. Well, it already does. Make something cool with it. What I would like to do here's the thing though. I was like, what if the particles could be affected by the wind? But the problem with that is that let's make some trees. The problem with the wind is that why are these somewhat like, is it because they're always slowly losing opacity? The wind is calculated on the vertex shader, and we could bring the wind in and transform it based on the input plus the wind or something like that, but that sounds like a pain. We're not even going to be able to see these blossoms. But we could test like making a particle system per tree and it drops some leaves. Look at this. Oh yeah, I did a little tree tester that was called Tree Stress Test. Just to see if we could handle drawing some trees. Why does render frame, what is taking 6 milliseconds if it's not render frame? Oh, you know what it is. This could be massively sped up as well, because it's like sending every tree to the renderer every frame to the tune of 129,000 trees or something. Delete. Yeah, 130,000 trees don't need, like the grass, oh that's plus including the grass. So the grass doesn't change unless you like do something like delete a cell. Then it removes the grass, or you put something on it, it resends the grass to the renderer. But the trees are clearing themselves and loading themselves every frame. All besides the point. The point is, can we use our particle system to make something? Why don't we have scales? We got this silly stuff. Start scale, end scale. Why don't we do that as well? And then we can scale them down instead of fading them out. We'll just have this to color white as well. The other thing is we're shading these particles in. Oh, hey, people are in. Why is my chat never update, man? Send me my chat, brother, every time. Sorry, Les, I missed you. Found your channel and recently binged all your videos. I'm really new to programming. I've been trying to learn C++ beside me. Pete LM96, welcome. It's good to have you here. I'm glad it's inspiring. Welcome. I hope you don't encounter an endless pain of working in low-level game development. The particle stream. Nah, this is just a real naive loop. Well, I did try a data-oriented thing and it didn't make much difference. So we're just looping particles, bruv. We are using the instancing system, which is probably helping, but we're still doing matrix transformations on each particle. What were we gonna do? Oh yeah, we wanted to try also looping the scale. Scale equals a Vic3 loop between the start scale and the end scale by the life t. No suitable constructor. Oh, this is okay. Week 3, then whatever. Is this a float? Am I making these floats? Okay, it's uniform scaling. Loving it so far. I've only ever made console programs, so it's damn nice. Yes, Raylib is the great enabler of being able to put stuff on the screen and do things that make sense. You know, to be able to just go, I want to draw some text. Oh, now we are scaling. Ew, I like the scaling. But interestingly, like, why is the color of... Why are they so dim? Why are they so dim, though? Oh, it's because they don't have normal maps and stuff. They're not getting the lighting calculated properly. Oh. Oh yeah, I made some improvements. I was messing with the wind. A lot. The wind, oh my gosh, it's such a rabbit hole. You can see the wind strength kind of blowing slowly over the plains. We can make it move faster. We can increase the wind factor, but... Oh yeah, here's the thing that really got me. Make the particles face the camera. Yeah, well these, I think the blossoms maybe rotate. Here's the thing that confuses me, right? If I set the wind direction to a static direction, the grass moves in the way of it. But if I have this updating, now the grass angle doesn't, I don't know. I love this, look at this, it looks perfect. Wind sway speed, wind sway factor. Space speed, oh that doesn't do anything? Oh yeah, look at it, it's beautiful. Wind sway factor. Oh yeah, now we're getting some lovely show wind strength map. I was trying to get those like ripples in the thing. You can start to see them. There needs to be some shading as well. Right now the grass are just billboards. There's something about, because the wind is coming in as a direction and an angle, and it's scrolling the UV texture, but it's also a normalized angle direction, and I'm just not maths enough to figure it out. Should be right. So I guess the rotation, I want to have a thing that's like initial velocity, and then like a vec3 rotation velocity or something equals vec3 0. So it doesn't, it's not for everything. But to do the rotation, we can say vec3, we need to add the here, the p dot rotation. And this is where rotating is not like just setting linear values. Add -0.5 to the vector. That removes the offset from the noise. Well, I don't know whether it's quite that straightforward, because you have this to contend with. The displaced world position minus the wind distortion, the negative wind distortion x and the negative wind distortion y added to the world position. I debugged this. I was debugging this yesterday because the wind is from -1 to 1. Oh no, I forgot to finish what I was doing. I could try just doing a naive thing. Rotation velocity times delta. And I think this is how to not do it. When I make these particles, I'm going to take the one out of game.cpp. I'm going to take this one away. Go to particles, and on the UI, we're going to add a particle. So we want it to rotate around the X maybe. Test system dot rotation velocity equals vec3. Let's make it 1, see what happens. So as a float, it will be from 0 to 1 at x, y, and z. So if you add -5, yeah, well, it's already, you can see I've got the values writing out that are being sent to the shader. They go from -1 to 1 on the x and y. I'll pull up the graphs controls here. I don't know if you can see that. Windows zoom. Oh, there it is. Yeah, so these values do go. Whoa, it didn't like whatever I did there. It doesn't like me anymore. I'm crashing. Everything is crashing. Oh. So they do go to, from -1 to 1. So they're already normalized. And they work when you override them and just say, I want it to be straight up in 0 and 1 on the X. It works. It's something to do with the changing of, see when I change the value, it like rotates it as well. When it's static, it works. When it changes, it doesn't work. I don't know why. Brain too small. What were we doing? Oh, we were adding a particle system that was going to be all crazy. So that, is that rotating? It is rotating. This is probably a bad way to do rotation. So I did 10 times that. It'll rotate 10 times faster. Add system. Oh, there they go. Look at them flip. I like when you slow down time, it makes more, which seems counterintuitive. Add more particles. So yeah, take this effect. Look at it, it's pretty cool how it does that. I wish I could zoom more. I'm going to push this button again. Now add a noise force. None of this, whoa, okay. None of this has kind of anything to do with the actual game. We could do a thing that's like, I think you could do it in the shader. Right now, I have to write a particle shader. Or you could do something like calculate some noise in an array and do the thing. I like how particle systems have noise in them. That's probably sent to the texture. I mean, to the shader. That's probably some good shader stuff. I probably have to do that and actually think about it. So when we create a particle system, we want the particle system to now have an area. So world position, and we want we can have a Vic2 emission area, and we could just set this to something like sort of one, slightly less than a block, so 0.8f by 0.8f. And when we emit a particle, instead of setting the world position, we'll go Vic3 position equals .x equals, so x is going to be a random range between the let's do this. F32x position equals, we want the world position .x plus a random range of negative area dot x, negative emission area dot x, and emission area dot x. So somewhere between negative that and plus that on the x, and add it to the world position. Do it for z as well. Z, 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 and those aren't going to work. These are going to have to be y's. Nice and confusing. And F32, and then I guess we can just construct the world position out of Vic3 x position world position dot y and z position. So hopefully this will make them coming out of like a square. If it's a float, it'll be from xy and xy and xy. All programming is just x and y and sometimes z. Okay, add a system. Oh, there they are. Haha. They look like they're moving. It's hard to keep track of them. Okay, let's change the velocitage. It's funny, like we're making one particular thing, like we're making cherry blossoms, And then you're like, okay, now I need to make a completely different effect. We don't support that actually. So how are we setting the velocity? We're just saying 1, and then we're giving it a random range. So we can velocity equals vec3 up. Velocity dot y. We'll just make it chill, and we're going to flip it upside down. Yeah, equals 0.2f. Let's just chill them out a little bit. Yeah, they need a drag force. We need like a velocity slowdown. Add system. Okay, this is a bit weird. It's hard to see what they're doing. Why are they? Oh, okay, they're getting crazy. Let's just not have these and see what happens. Okay, now they're just going straight up. It's hard to see them in they're so flippy. To actually make them look good will be a whole nother thing. Where am I setting this initial rotation velocity? I think that's just exactly what we need. What we need is a constant gravity force. Plus, let's move them up. World position equals, so they are going to be at like test system dot are we explicitly setting the velocity equals negative 0.2? It's hard to know where they start and where they go. So I add a system. Oh, they are falling. Add some trees. Perfect. There they go. How big is this thing? Oh, I made the area. The area's got to be world position equals random range. The area. Oh, I'm setting it in here. So this is, we'll set it over here. Test system dot area, emission area equals vec2, and it's like half a cell by half a cell, 0.5f, 0.5f. We don't actually know, right now they're not spawning particularly. Add a system. Okay, so that's more cube-like, but it's... Should we just connect these to the thingamabob? Did you make this whole editor? Well, I didn't write the GUI systems. I wrote the interface, like I wrote what to be where, but it's running dir im GUI, which is like a library to draw that handles drawing textures and checkboxes and the windowing and stuff, which is pretty standard fare for, especially for things like tooling and editor systems and whatnot. grass looks quite good. Oh, you know what? Okay, before I get to what was I doing? Okay, we can chill this way out. We want to add one of these to each trees. Particle manager, add system. Lovely. This is not going to be yeah, why not, eh? Okay. So world.h, we don't actually have a necessary, I guess a grid knows a tree, a thing knows if it's got trees. This is the only way it knows the specter of mat4 tree matrices. Oh, and if it's got a feature called trees, and we have a thing called plant trees, which could create a thing. But how do we currently remove trees? Editor.cpp, we've got a feature mode. We've got a thing called trees. Tree.matrices.clear. And we've got remove feature. This feature.none. We could just say if feature.type equals trees, feature trees, come on man, give me some help. Then we could do kill particle system. And we're gonna have to store the i32 tree particle system ID equals -1. Then if tree particle system ID does not equal -1, then genie particle manager dot remove system tree particle system ID tree particle system ID equals -1. So we've got a way to remove particles, and then on plant trees, we can create a particle system. Oh wait. Plant trees, tree matrices.clear. We can say particle system blossoms. This is going to be like, there need to be a different one for every type of tree. Right now we've got this one tree. Blossoms dot emission area equals vec2 cell. I'm on the cell. World position dot x minus 0.3f or something. And z is world position dot z minus, oh wait, what is this min and max? It's only a square, is that right? We can only do this in a square. Plus 0.3 minus 0.3. What am I doing? X and Z. How did we do it on the thing before? World position random range. No. Area. 0.5, 0.5. Oh yeah, don't worry about that. That's 0.3, 0.3. Don't worry about that. blossoms dot world position equals world position plus half a cell size y plus vic3 0.0f, and then on the y we want to go, this is the middle of the cube, so we want to go 0.25, then we want to go up a little bit, 1.25 or 1.2f and 0.0f. Okay. Blossoms dot emission rate equals 0.2f. Is that what we're doing? Something like that. 0.02. Blossoms dot in scale. Those are set already. Rotation velocity equals vic3. We'll go, was it like 3.0f, 0.0f, and 3.0f. We'll give it a three-dimensional rotational velocity. Dot initial velocity equals, I think we might be overriding this somewhere. It's negative vic3 0.0f negative 0.2f 0.0f. Blossoms. Now we do need the particle systems to, when it creates a particle system, to send me back the ID so I can store it for later. I32 particle systems, pushback particle systems, return particle systems size -1 as an I32. Right? Anything else we need to save? Model equals G game models dot blossom. Okay, and then we actually need to say genie particle manager dot create system blossoms, and this we can do to add system. Boom. Nothing could go wrong. Hey doggies. Trees. Bush. Okay, that's making a lot of systems. Oh. I've got it on mouse down right now. If tree, and we also need to set this tree particle systems ID equals genie. If tree particles system ID equals -1, then make this thing. Because right now we're making like 5 billion trees a second. It's quite a lot of particle systems. Particle systems. Oh, it just was just perfect. There they are. Yeah. That didn't work at all. Why is it so high? Am I overriding this in the particles by doing something crazy? Make a new particle. Okay. This is all wrong. This should be initial velocity, because we now set them, because we're good people. World position, Z position, world position dot Y. You're not even going to be able to see these dang thingies. And why are they so high? I think I'm just going up too high. So 0.25 takes us to the middle of the cell. 0.5 takes us there, so it's like 0.7. We're just going 2 hundies. Oh, there they aren't. They need to accumulate on the ground. We're making Ghost of Tsushima. Let's make the size a little bit more spicy and make the blossoms dot lifetime max equal 2.0. What is it normally? One and 2 to max 3. Oh yeah. Trees. I think you're up here playing train game, you don't even see this. They kind of need to move with the wind or something, eh? So they're all just going to be like... This needs some proper shading. Oh, wait. I know how we can increase the excitement levels. Oh, yes. There they are. No! Perfect. How many systems? 24 systems. Update particles is taking 200 microseconds. Whoa, why is it so windy? Where's our grass controls gone? These values are so tiny. Yeah, we kind of need to sample the wind. It'd be cool if the position of the particle was all calculated on a GPU. So we just set it, give it its position, and it does a matrix. It can do billboarding. And then you could add in like the wind texture. What if we just made the... Gotta start somewhere, indeed. Well, I mean, you know, this is kind of what I was aiming for to do just in this session. But what if when we make the trees, plant grass, I feel like plant trees should have a note because it's such a important thing. Plant grass. Plant trees. First off, let's make way more blossoms by a factor of like 10%, 1%. Spread them out a bit more. Because you know in Unity you can grab that little noise, make a little noise texture, and it pushes them around. Is that based on... That must be done on a shader somewhere, right? Is that done on a shader? Well, let's make the trees potentially a lot bigger. Boosh! Oh, mega trees. I feel like we see even less blossoms. Bushy trees. So as to load up something like, what if I loaded up tree stress test? Ah! Ouchies. World. Oh, every tree auto creates a thingamabob. They're quite big now. I look at they explode into the other cells. Bing, 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 it's pretty good. 43,000 instances, and we're rendering at 2 millisecond a frame, 400 frames a second. Adds absolutely nothing to the gameplay. This is where you like, for every tree you need to have a different type of particle system, and then you're like, okay, once it starts making random trees, then for each tree needs a particle, blah, blah, blah. Then you're like, oh, this is where I want a prefab that has a particle system on it. But we just can't. It just can't be done. We just can't fall into that trap. Each tree have a single particle system. It's per cell. So you could have less trees in a bunch or something. Max trees in cell is currently set to 10. You could have like 6 trees or something. This might not look so nice. Ugh! What time is it? How long will we be streaming? 3.5 hours for particle systems. No problem. Oh yeah, see, now we've got little sparse trees. And mega particles. It's hard to know, because then each... It's better when they're a bunch. It's also not so clear when you're playing. You might be like, why can't I just go through there? That's why I was making the trees more like a unit of trees. I think 10 was better. All right, open world. Oh, we need to add a little thing. All right, Dragon Laser. Good to see you there. Good to see you today. I definitely won't promise you about the Blender texturing, but I do think about it. You're in the back of my head there going, hey, textured in Blender. My particle accelerator. Oh yeah, can I look? Can I look? Do-do-do-do. Oh shucks, there we go. Oh whoa, it is an accelerator. How'd you do that? Is that a geometry nodes thing? Yo. Aha. Do you mind if I show it? Maybe I don't want to bring the Discord on. Go to the Discord and see Dragon Laser's particle accelerator. Yeah, it looks rad. Oh, is that some shader magic? Oh, that's right. I was doing something, wasn't I? Whoops. A warehouse, a factory, create cargo timer, create cargo duration. Oh, it's not getting the cells. Oh, that's right. Cargo.cpp. When we create a thing, create station. It's on editor. Of course, it's really annoying. Feature mode, stack inspect, factory build. So when we do level add factory, we should do this in the world, in the level loading. I'm already, wait, what? Why are we doing it on level load? We're doing something loads storages resources. So storages should happen first, and then resources should load, and these are called factories. And we're just setting the shouldn't we just say cell, we could say factory, we need to say cargo, factory, and then say, we've got this load data thing, which sucks. Oh, we could call load data on this, right? Factory dot load data, factory data array I. So we load the data into there, and then we want to do a thing called level. Oh, we want to do add factory, and what it needs is a cell. So we need to go cell pointer cell equals grid get cell air coordinate factory dot coordinate. We need the cell. We need an array of neighbors. So vector of cell of cell pointers neighbors equals grid dot get cells in range 2D. The cell in the range is 1. Then we can send the neighbors. And the cargo type, which is factory dot cargo type. So is that a better load? See ya, dragons lasers. Dragos. Now you'll start making cargo. You will. Oh, buddy boy. We're doing it. So our little loop-de-loop should work. Now we can just rerun the game. Rerun. Get the trains back going. Get the trains back on track. Oh yeah, we don't load tunnels properly. Oh yeah, what were we even doing? We were like... trying to do something fun over here, weren't we? A bustling world, yes. Our first test world. With butter yellow stacks, brother. Butter yellow stacks. How big is this level? Oh, we don't see because I broke the way the thing works. If we put a stack there and a port there, boom. Now I've got this interesting little 3-tiered dude that would go 1, 2, 3, 4. Dun 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 dun. Build a bridge. Build a bridge. Build that. Do that. It's not a very difficult puzzle, is it? You know. This one accepts none. Supplies none. Train. Oh no, I put 2 trains. They're gonna crash. Oh, I forgot to put stations over here. That would be why we're not getting any throughput. Accepts none. Supplies none. Oh, the cargo must flow. The spice must flow. Oh, that's not... This has got nowhere to go. Okay. Replete with cherry blossoms. With 47 particle systems doing their systemic things. Pretty good. Trains, and aquatic mobiles. Oh. Whoa, look at that. Beautiful water rendering. How to destroy the illusion. How to make the game run faster. Oh, look at that. Oh, that's our frame buffer. Okay, it only works full screen. Would you add planes to complete the trio? I don't know. I don't know how I would factor them into the puzzle. You know what I am going to add though? Is there's going to be world. I'm losing my thing. Ocean controls. Let's get these deep, beautiful oceans and make the scale bigger. I am going to add. I'm going to make levels like this level. I'm thinking of making maybe not each world, but different worlds have different like biomes. Maybe there's like deserty worlds. I was thinking about a mountain world where it goes down into the mist and you're up on the high cliffs. And instead of boats, there's like big Zeppelin thingies. Oh, am I over there? That move the cargo. Oh, we need one more train there. Why is the wind so... Whoa. Yeah, these ones... They're not looking so hot. We kind of need them in a circle. Because you can see them popping down here. There's really got to be some payoff for delivering this cargo, because otherwise you're just working on these annoying things, getting more and more confused about what the heck is going on. You know what? That's what I was trying to do yesterday. I was trying to make the shoreline shader, and dude, was it confusing. That's why there's no transparency anymore on the ocean, because it's like you got to render. You need the depth buffer to do this depth testing. But in order to do that, you have to render to a frame buffer, and then you've got to draw the ocean shader with that as a depth texture and do all this testing, which I don't even know how that worked. But then if you take the ocean away, there's no depth information over here, so it only draws stuff where it intersects with objects and not. So it's like, oh, you got to draw a plane where the ocean is for the depth buffer and then draw the ocean, but then it always tested. It was just a nightmare. It really killed my morale. Hence why we're making particle systems, because they're fun and achievable. Do you mean like shader SDFs? I don't really know how it would work. You could do something real budget, like have a little particle system that shoots lines out from the edges of the cells. Yeah, particle systems, I mean, they're definitely a work in progress, but they do function. I saw this really cool blog about it. OpenGL. Where was it? This one. Not this one. Water. OpenGL. Not that one. And then I can never find it again. Water graphics blog. Ocean graphics blog. Graphics shader blog. It's not that one. OpenGL water implementation. I don't know why it's so hard to find history. Yesterday, where was I? What is edge? Is this the one? No. Water breakdown. It was this one. Yeah, this was cool. I was like, oh, that's cool. Look, they do all this cool stuff and they tessellate the ocean. Probably don't need that. And then they make it move, and that's cool. And then they do this refract, and then foam. They're like depth comparison. And we need the fall off distance. And then we need to do simple fall off and then leading. But it's just like these little snippets. It doesn't really tell you. And then this, I'm like, whoops. Like, well, how is the... If you've got any questions, feel free to reach out to me. Yeah, I just was like, that'd be cool. But it wasn't as simple as I thought it would be. Much more difficult. Oh, Sebastian Larg. Yeah, Unity. I've seen people do it a lot in Unity. Because the shader graph has got good nodes to get, like you can get these Unity water edge shader. How to make shader foam in Unity. Hey guys. Adding color, what do? Yeah, you get some thing. You get the thing, you add the color, whatever, adding waves. Adding foams. Gradient noise. Depth fade. Yeah, see? There's just a button called depth fade. And I'm like, bruv, I need a button called depth fade. I want this. I want my nodes back, bruv. If the shader doesn't, yeah, see, that's what you want. One downside of this effect is it doesn't show the foam when the thing is perpendicular. Like if you were like that, you'd get no foam on these edges. Yeah, maybe instead you could just do a thing where there's a little plane and it just renders a scrolling texture. But it'd be cool because I'm thinking of adding like rocks, and it'd be cool if it worked with the boats and everything. I wonder if you could do it with ambient occlusion. Well, they're similar because ambient occlusion is using the depth buffer to test things. I wanted to do. I was reading about ambient occlusion. I was like, my brain was going like. Okay, yep, sounds good. This thing's got its own ambient occlusion from just the little shader effects. I mean the texturing from Substance. What's going on with our cargo? We're slowly building. Endless blocks. Maybe that's the thing, you can upgrade factories to produce cargo faster. And then it's like becomes how much cargo can you deliver in a given amount of time or something. For the speedrunners out there. You could add a skirt plane around with that touch water with a scrolling texture. Yeah, because this is just a flat plane. It could be just above the water plane. It could even be a little particle system or something. It's cool. All the little touches like the wind and the cherry blossoms and the grass, they give it a bit of life. If you turn off grass, it's like... It's still kind of cool. Don't draw the terrain cells. Yes. I do think the terrain cells... need work. Like with rounding. There's just a bit of challenge in there for things that are like cells above cells with rounding. And then what? Then they have to manage the grass of the one underneath and everything, and it becomes a bit of a nightmare. Yeah, I think maybe next time I'll make a Return of the Slopes. No slopes, bro. I think maybe next time I'll do... I might get like... I could do it now, but I'm kind of hungry. Get the hints. What was that from? Is that a Dota thing? File import. I would like to make one. Assets. Why is it on this mode, man? Daisy trains, models, Kenny, train kit, models, train locomotive. What do these look like? A little cartoony. I could texture this bad boy up for a tester, and then we can get a little, maybe we get a little smoke particle system going. Why is it doing this? These models are a bit weird though. See, why does it do that? Yeah, the Hogwarts. Maybe just grab a Obij A format locomotive. Oh, funny little silly little sucker. That one's got broken normals. So many cool effects. Sun shafts. Wow. Yeah, I was thinking once you get to a certain height, there could be clouds. Oh, we need to do, yeah, shadow maps. Also, maybe try and create the mechanics to actually complete a level. Have deliverables. Oh yeah, I want to do ship waypoints. There are actually like a whole lot of actual good notes that came up from the other stream the other day. Port unlock criteria is quite important. Port direction switching. Train tools, so you can have trains of different sizes. Ship waypoints, so ships can go around places. Connected stacks. Rocks in the water to stop you being able to build bridges on certain areas. These are all good things that could be done. But I reckon we make a train with a little smoke coming out the top. A little locomotive going doot doot. And a wind shader for particles. Effects. So, I mean, this level, and fix the camera zoom. So this level has two colors, each trying to get to some sort of destination, or maybe multiple destinations. What are the metrics for success? Deliver X amount of cargo. Deliver X amount of cargo within. Get your delivery rates up. Does that sound like fun? I don't know. How optimized are your things? How much challenge do you want to put into it? Anyway, all good stuff. Particle systems. I'm going to save this as world. Make something cool with it. I think I'm going to give myself one on that. Done. Stream 28. Particle Accelerator. In 3 hours. Where do I put a number there? 55 minutes. 29 seconds. Good times, good times. Well, shot for everyone. Thanks everyone for coming and hanging out during this exciting time. This was quite a fun one. And mainly worked out pretty good. Mostly worked out pretty good. Thank you very much. Thank you. And yeah, I don't know, next stream, we'll see how we go. Learned how to create a particle system. I wouldn't necessarily follow anything I'm doing. Shot Pete, good to see you here for the inaugural, for the first catch up. It's good times. Yeah, definitely do some reading on how to actually make good particle systems. We'll have to send them some of the work to the GPU and get the wind going and whatnot, but anyway.
Phenomenal cosmic powers! Itty bitty living space.
We're not too sure exactly how we're going to do it, but it's going to happen.
Yeah. Alrighty. Oh, well, I'll see you guys later. Come by the Discord, say hi. And, yeah, we'll see you on the next one.